Please welcome Submer CEO and co-founder Daniel Pope and Barcelona Supercomputing Center Senior Technical Leader Carlos Puchol.
Hello, everyone. Thank you for the warm welcome. So, George, CEO of OCP, mentioned that obviously this OCP Regional Summit's about European collaboration and innovation, and that's exactly what we're going to be talking about today, a project of European collaboration. The EUPILOT, which started a year and a bit ago now and is led by Carlos here, from the Barcelona Supercomputing Center, is a project, a European-funded project, 30 million euros of funding, from direct funding from the Euro HPC joint undertaking, and 30 million matching, more or less, of funding from the different national funding entities to drive exascale, open exascale supercomputing based on open software, open hardware, and next-generation cooling. And with that, I'll hand it to Carlos so he can talk a little bit more about what we're doing at the EUPILOT.
Thank you, Danny. All right. Good morning. We'll talk a little bit about how the project is divided. We tend to think of it as three parts: hardware, software, and systems. It's not quite exactly what you typically would think, but hardware and systems are actually areas that are based on OCP technologies or standards. So the hardware we leverage technologies from the European Processor Initiative that you've heard not too long ago from Eddie, and that basically, we leverage the accelerator efforts from the European Processor Initiative. We have, in this project, 3 chip tapeouts. In the prior efforts in the European Processor Initiative, they did tapeouts in 22 nanometers. In this project, we kind of go from 0 to 100, all the way from designing new technologies in terms of RTL and doing chip tapeouts, all the way to 100% deployments. So these tapeouts are in 12 nanometers, and we have one small test chip to test the 12 nanometer node, which arrives in about 4 or 5 weeks. That's pretty exciting. And then 2 larger accelerator chips. One is called VEC, and one called MLS. The VEC chip is designed specifically for traditional HPC workloads, and the MLS chip is designed for AI and machine learning workloads. They basically leverage the RISC-V ecosystem, and they're designed for, to do all sorts of optimizations and reuse a lot of the I/O infrastructure in both cases. Eventually, these are built into boards, OCP, OAM boards, and UBB boards that get deployed into liquid immersion cooling tanks from Submer that enable higher workloads, higher density, higher capacity with reduced environmental impact. So the objectives of the project are to demonstrate a pre-exascale accelerator platform. So the idea is to design, validate, and do as much as possible, maximizing the use of European technology. So this is where we would like to interact and collaborate with all of you.
And one of the main goals, Carlos, right, is also to try and have an open source or an open hardware option when it comes to building the next generation European supercomputers, if I'm not mistaken. So
exactly. So this is basically, you can think of this as essentially a follow-on project from the European Processor Initiative, the EPI project that you've seen, that you've mentioned before, and we leverage, all the efforts that have been done there, and there's going to be follow-on projects based on this one. Ultimately, part of the goal is to strengthen the European digital autonomy in the supply chain. And this is basically where all of you and OCP really helps a lot. And then to really bring things to life a little bit, we have a video that shows what the project is really all about in images. It's a short video. Go ahead, please.
Can you imagine a future where the entire semiconductor value chain is provided by European sources? The European Pilot project is a key project towards realizing this goal. World-class competitiveness, leadership, and self-reliance in industry and science are now more important than ever in Europe. Bringing a new level of high-performance computing, data analytics, and maximizing the use of European technology, EUPILOT makes use of open source and open standards to create an integrated software and hardware system. From microchip designs to the systems incorporating them to deployment in data centers, EUPILOT pushes the envelope in high performance and energy efficiency. With a streamlined software stack, EUPILOT systems are being designed to accelerate computationally intensive applications in the fields of molecular and climate modeling, genomics, biomechanics, geophysics, and many other domains. EUPILOT is creating two complementary RISC-V accelerator chips designed, implemented, and deployed in Europe. One for vector-driven tasks like scientific computing, called VEC, and another for data analytics, AI, and machine learning applications, called MLS. Each VEC accelerator contains an array of compute tiles, and each tile contains a CPU and a vector processing unit. The MLS accelerator contains clusters of a larger number of small yet efficient cores specialized on computations most frequently used in data analytics, machine learning, and AI. These chips, coupled with memory chips, form accelerator modules, and multiple modules are hosted on a baseboard within a chassis to form an accelerator system. Each accelerator system is then paired with a host server and is immersed into a liquid cooling tank which can hold up to a dozen hosts and accelerators. Gone are the days of server racks taking up an inordinate amount of power. Now, multiple liquid-cooled tanks can be deployed in a data center for a large integration of compute capacity and density at unparalleled levels of power and cooling efficiency. The European Pilot, contributing to a sustainable exascale supply ecosystem in Europe and ensuring European digital autonomy in this field.
So there we briefly saw some of the 19 companies from the consortium. The project is, as I mentioned, led by Carlos from the Barcelona Supercomputing Center. What can you tell us about BSC, Carlos? Because today, you guys run one of the most impressive supercomputers on the planet. I believe it's 8th on the top 500 list today.
That is correct. It was debuted, it's called Mare Nostrum 5. It's about 12.5 megawatts in a 20 megawatt facility, and it debuted at number 8 in the top 500. So now we're basically trying to get Mare Nostrum 6 with as much European technology. In fact, we're trying to get accelerators that are going to be all European.
So this is about a supply chain sovereignty, of course, chips, full supply chain from a European perspective.
Correct. So just a quick recap. So we have accelerator modules here on OEM boards, UBB boards that get deployed along with host servers. And the host servers actually come from the EPI project. And then when paired together, they get deployed in cooling immersion tanks. And tell us a little bit more about immersion.
Yeah, I think Gregory from OVH actually spoke a lot about immersion already. We truly see it as the end game for cooling next generation platforms. The main reason being when you look at the full TCO from the chip all the way through to the rack, the data hall, the infrastructure, the secondary cooling infrastructure, etc. There are a set of cumulative benefits along that chain that bring unprecedented TCO to a facility, right? But it really takes the fact of decoupling what we've historically done in the data center industry, which is focus on the IT side, someone focuses on the IT side, and someone focuses on the facility side. Liquid cooling, fortunately, kind of forces us to break that, and so we believe that immersion cooling is definitely the end game when you look for efficiency, density, sustainability, the capability to capture and reuse that heat as well. But I think Gregory did a great job in talking about that. Main goal being dry cooling infrastructure, being able to deploy these supercomputing platforms anywhere on the planet as sustainably as possible, and obviously in scenarios where you can reuse that heat, reusing it. But that's one of the main reasons why this consortium decided that immersion should be the next platform to base European supercomputers on.
Thank you. Just to recap, the goal is to set the stage for the next generation of sustainable supercomputing solutions and help strengthen the supply chain. The goal is to demonstrate this system at the end, towards the end of next year. We have about, the main critical point, and this is something that we'd like to run through you guys, is, in terms of UBBs and OEMs, even though the UBB is supposed to be a universal baseboard, it's not quite universal there. So we would like to get help in suggestions as to how to map some of this work to make these things possible. We are having trouble getting UBB solutions that are especially European-based and that are fully interoperable. And so we'll be around all this couple of days, and please.
Yep. And also the ask, I guess, from an immersion side of things is the focus on the components being warranted, supported in immersion. That's a big ask from the immersion vendors. So absolutely necessary as things move forward. And every day there are more systems that are supported and warranted in immersion, but we hope to grow that day by day. Thank you for listening to us.
Thank you.